You know, it looks like something ripped straight out of a sci-fi movie. Just this silent, bat-like wing gliding through the night sky. But the B-2 Spirit is very, very real. And it represents one of the greatest, and yeah, one of the most controversial achievements in the entire history of aerospace engineering.
So let's just start with a number that's kind of hard to wrap your head around. Over $2 billion. That's the price tag for just one B-2, once you factor in all the research and development. I mean, to put that into perspective, a B-2 is literally worth more than its own weight in solid gold.
So that brings us to the big question for this whole explainer, right? What could possibly make an airplane worth that much? Well, the answer isn't just about the parts and pieces. It's about solving two just monumental engineering challenges. First, figuring out how to even make it fly, and second, how to make it disappear.
Okay, so to really understand the B-2, we have to go way back in time and talk about aviation's oldest dream, the flying wing. For more than a century, this thing was like the holy grail of aircraft design, but it came with a problem that seemed, well, pretty much impossible to solve. The concept itself is beautiful in its simplicity. I mean, think about it. You get rid of the main body of the plane, the fuselage, and you get rid of the tail. What you're left with is an aircraft that's just one giant lift-generating surface. In theory, this design has the least possible air resistance, or drag, which makes it incredibly efficient.
And believe me, people have been trying to build one for a long, long time. This dream is basically as old as flying itself. You had pioneers like John Dunn with his early gliders, which were apparently so stable he could take his hands off the controls to write notes. Then there was Geoffrey Hill's pterodactyl, and even a jet-powered Nazi prototype, the Go-229. So the concept worked, but it was never really perfected. And this right here, this slide gets to the absolute heart of the problem. A normal plane has a tail for stability, right? It's like the feathers on an arrow. But that tail also creates drag, and that slows the plane down. A flying wing gets rid of all that drag, but without a tail, it's like trying to throw an arrow that doesn't have any feathers. It just becomes incredibly unstable. For human pilot, it's almost impossible to fly. For the longest time, this was a problem with no solution. So while engineers were banging their heads against the wall over this instability problem, a completely new challenge pops up during the Cold War. Suddenly, it wasn't enough just to be fast. To survive against sophisticated Soviet radar systems, you had to be invisible. So the key to being invisible to radar is this thing called radar cross-section, or RCS. The easiest way to think about it is like an object's brightness on a radar screen. The smaller the RCS, the harder you are to spot. The goal for a stealth bomber? To shrink the radar signature of a massive 172-foot aircraft down to the size of a tiny bird. So how on earth do you do that? Well, the theoretical breakthrough, and this is the incredible part, it came from this obscure paper published in the Soviet Union back in 1962. A physicist named Pyotr Yefimov developed these equations to predict how any geometric shape would reflect electromagnetic waves. The Soviet censors, they saw no real military value in it, so they cleared it for publication, unknowingly handing the West the mathematical keys to building stealth aircraft.
Ofensev's work basically gave engineers the playbook, and it was first tried out on planes like the F-117 Nighthawk. It really boils down to three main ideas. First, you shape the aircraft with all these flat panels and blended curves to bounce radar waves away from the source, not back at it. Second, you use special composite materials and even paints that actually absorb radar energy. And third, you have to shield the really reflective parts like the spinning turbine blades inside the engines.
And this is where our two stories collide. The absolute perfect shape for stealth, a smooth, tailless flying wing, was also the most aerodynamically unstable shape you could possibly imagine. The solution was going to require a massive technological leap that would finally tame that beast. So here's the paradox, right? The very design that could make an aircraft invisible to radar also made it almost completely unflyable. A human pilot, no matter how good they are, just can't react fast enough to keep a flying wing stable in the air. Which, of course, leads us to the pivotal question. How in the world does this massive 172-foot flying wing stay in the air with the grace and stability of a totally normal airplane? And the answer is this revolutionary technology called fly-by-wire. Here's the key. The pilot isn't actually flying the plane. They are telling a computer what they want the plane to do, and the computer is the one actually flying it. It's like an artificial brain making thousands of tiny adjustments every single second to the control surfaces on the wings, the elevons and rudders, to keep the plane perfectly stable. Without this system, the B-2 would be totally uncontrollable. It would just fall out of the sky. And so, now we can finally answer that $2 billion question. The B-2 Spirit is what you get when you finally solve those two monumental and monumentally expensive engineering problems. And just look at what you get for all that money. The result is an aircraft with some truly incredible capabilities. It can fly at 50,000 feet, travel nearly halfway around the world without refueling, and deliver 40,000 pounds of weapons with pinpoint accuracy, all while being virtually undetected. And it does all this with a crew of just 2 people. Oh, and it gets even better. The B-2's own radar system is stealthy too. It uses what are called low probability of intercept techniques. This basically lets the B-2 map the terrain and find targets, while putting out a signal that is incredibly difficult for enemy sensors to pick up. In short, it can see without being easily seen. And this right here perfectly illustrates why that cost is so mind-bogglingly high. It's not just a plane, it's a concentration of groundbreaking solutions all rolled into one. That price tag reflects the massive R&D, the exotic materials, and the revolutionary manufacturing needed to build what was, for decades, considered an unbuildable aircraft. Now, the B-2 was originally designed to sneak into Soviet airspace during the Cold War, but its true legacy would be cemented in the conflicts that came after. It made its combat debut back in 1999 over Serbia, flying non-stop from its base in Missouri, hitting heavily defended targets, and then flying all the way back home. It proved its unique capabilities again and again in Afghanistan and Iraq, really demonstrating the incredible value of a long-range, penetrating stealth bomber. This small fleet, just 21 B-2s were ever built, is planned to stay in service until about 2032. And all the lessons learned from its design, its construction, and its operations are now being directly applied to its successor, the next generation B-21 Raider. So the legacy of the flying wing is set to continue. Which really leaves us with one final thought. The B-2 Spirit proved that yes, invisibility was possible. But in this endless cat-and-mouse game of military technology, as new radars and new sensors are always being developed to counter stealth, the ultimate question remains: how long can anything truly stay invisible?